Hi, today we're going to look at another two-sample t-test. The problem described here is about novice versus skilled competitive rowers, and researchers had randomly selected two groups of female rowers, a skilled set and then what they called a novice set. So they decided to measure what's known as the angular velocity of the knee, and you might not know what that is, but it's okay because later in the problem they say to us the researchers believe that the knee velocity would be higher for skilled rowers. So that's how you'll be able to start to build your hypotheses, even if you don't know exactly what knee velocity is. All right, so let's start by doing that. We're going to say let mu sub s equal the mean knee velocity for skilled rowers. And then similarly, mu sub n will equal the mean knee velocity for novice rowers. Okay, and we go to write our hypotheses. HO is always that there's no difference between these two groups. So we would write that by saying mu sub skilled minus mu sub novice is equal to 0 versus HA, mu sub skilled minus mu sub novice. Now for this, you have to read the problem, and the key statement is right here. The researchers believed that the knee velocity would be higher for skilled rowers. If we thought mu sub s was bigger than mu sub n, then we'd expect this difference to be greater than 0. So there you are, you've got your hypotheses. The next thing you want to go and check are your assumptions. So first, both groups were supposed to be simple random samples, but that's stated in the problem. Look back up there. This says the second sentence says researchers compared two randomly selected groups, so that's a good thing. Second thing you want to check is independence. And to do that, you have to check that the population of all skilled rowers is greater or equal to 10 times the sample size of the skilled rowers. Now, there is no way to check that here, but we'll have to make this an assumption then. We'll notice here, the skilled rowers, there was 10 of them in the group. So this is equal to 10 times 10 or 100. So I'm just going to check that off or to assume that that's true. And since that's true, then we can say that the standard deviation of x bar for the skilled rowers is the standard deviation of the skilled rowers over the square root of the number of skilled rowers that were part of our two-sample t-test here. The problem actually gave us that data. There's a column here called standard deviation, and you'll see that 0.479. So I'm going to put that in here, 0.479. And we're going to divide by the square root of the sample size, which we said was 10. Now, if you do this, take the time to do this in the calculator, here's what you get. You end up getting about 0.151. And interestingly, that's what this next column is. So this is a neat problem in that they gave you the standard deviation and the standard error. Sometimes standard error, we usually denote that S of x bar. Well, this is just S of x. So that's sort of a nice thing. You're not done. You have to check also for the population, or say that the population of all novice rowers has to be greater than 10 times the sample size of the novice rowers, which is 10 times 8 or 80. And if that's true, then we can say that the standard deviation, oops, let me rewrite that. We can say that the forgive that error there, sorry about that. The standard deviation of x bar for the novice rowers would be the standard deviation of the novice rowers over the square root of the sample size of the novice rowers. So those numbers are also given here for us. So it's 0.959. You can see that here, and the standard error will turn out to be 0.339. So this is 0.959 over the square root of 8, and this will be about 0.339. Okay, now the final assumption would be that the sample size was greater than 30. We would love that, and then we know it's safe to do our t-test, but we don't have that here. We have n of the skilled rowers is 10, n for the novice rowers are 8. So technically you would need to do box plots. And here's where this problem gave us another little gift, because we read it, it says right here, the data show no outliers or strong skewness. So they're letting us know that that third assumption about the normality shape and it's safe to use the t-test is good to go. All right, so now it's time to go draw a picture. So we draw something that looks like a normal distribution. It's really a t-distribution. Take note of your degrees of freedom here. Your degrees of freedom will be the minimum of the sample size of the skilled rowers -1 and the sample size of the novice rowers -1. So in our case, the degrees of freedom would equal the minimum of 10 minus 1, which is 9, and 8 minus 1, which is 7. So degrees of freedom are equal to 7. All right, HO goes in the middle, which was 0 here. The one thing we didn't do yet, we need a standard deviation. And we go back, you would notice we have two of them. We have a 0.339 and a 0.151, but that's not what we really want. We're interested in the variable, the mean of the skilled rowers minus the mean of the novice rowers. So what that means is that our standard deviation for the difference in these two variables we get by adding the variances and taking the square root. So it's provided the two things are independent. So what we're going to say is S of X bar skilled rowers minus novice rowers equals S of X bar of the skilled rowers squared to make it a variance times S of X bar of the novice rowers squared to make that a variance, because you're only allowed to add variances, and then we take the square root of this to make it a standard deviation. So we end up getting the square root of 0.151 squared plus 0.339 squared, and ends up being about 0.371. So I'm going to go mark that off over here. We'll mark off 0.371. That's one standard deviation above. We'll go down one standard deviation. We should go up 2. So this will be 0.742, and this will be negative 0.742. And then finally, we need to mark off the difference in our X bars. We need to do X bar for the skilled rowers minus X bar for the novice rowers, and see where this ends up. Go back to the data that was given to us. We have a mean for skilled rowers right here, 4.182, and a mean for novice of 3.01. So this is going to be 4.182 minus 3.01. Subtracting that, we get 1.172, which is quite a far way out to the right. Looking at our t-distribution over here, that's going to be out here somewhere. It's going to be, well, let's mark it in red, be dramatic about it. Right there is probably our number. So it's pretty far away from the mean. We should go calculate a t-test statistic and see what we get. So to get a t-test statistic, t is equal to X bar minus mu over the standard deviation, in this case, of X bar sub S minus X bar sub N. So we have all these numbers. This is 1.172 minus the mean of 0 over our standard deviation, which turned out to be this number, 0.371. So we actually end up being quite a few standard deviations away. If we take a minute to type this in, we get that we're a little over 3 standard deviations away. Okay, so what I'd like to do now is take this t-score and turn it into an area, and then we'll have our p-value. So to do that, we know our t-score is 3.15. Our degrees of freedom are equal to 7. So on a TI-84, you want to use something called a TCDF function. And your lower number is going to be 3.15. Your upper number is going to be some huge value. And the TCDF wants degrees of freedom as its last entry. So we're going to put 7 there. So let's go do that. Let's get an answer. And we end up getting about, this answer turns out to be about 0.008. So the area in this tail is 0.008. Now that's an extremely small p-value. 0.008 is definitely less than alpha equals 0.05 or alpha equals 0.01. These are the two most common alpha levels that we use. So they're extremely small. So in this case, we would reject HO in favor of HA. Okay. And that's telling us that we're going to reject this statement that the two means are equal and rule in favor of the alternate that this is true. And so that's saying that we had a significantly higher mean for skilled rowers than we did for novice rowers. So this knee velocity is faster for experienced rowers, and that's what we've proven. Thanks for watching.